understand the transient response of the system, let us solve some problems. Now let us take the first one. Here it go. Now in this problem, the problem statement is the open loop transfer function of the system is given by g of s is equal to k by s into s plus 10. So the unity feedback system, we need to find the value of k such that the system will have the damping ratio 0.5. For that value of k, determine what is the settling time, peak overshoot, time to peak overshoot and other things for unit step input. So this is a problem statement. Now we need to find settling time, peak overshoot and of course peak time for the k value. And k value we need to find such that system will give a damping ratio of 0.5. So first of all we will find what is the k value. Now so the G is given and H is given. Let us take the characteristic equation. What is the characteristic equation? We know the formula Q of S is equal to 1 plus GH is equal to 0. Now G is available and H is of course it is 1. When you substitute G here and we will get it as S square plus 10S plus K is equal to 0. So S square plus 10S plus K 0 is the characteristic equation of the system which we have taken. What is the standard characteristic equation? So we have here S square plus 2 zeta omega ns plus omega n square is 0. Two equations are there. By comparing, then you can find out the required things. Now how can you compare? Let us compare with the last one. I have omega n square and in our equation we have k. So your k is equal to omega n square. Let us keep this information as it is. K is equal to omega n square. Now next we are going to compare the second term, that is 2 zeta omega ns is equal to 10. So zeta is given to us. For the given zeta we need to find the k value. Therefore zeta is 0.5. Let us substitute that 0.5 here. Then what we will get if we substitute 0.5 in place of zeta, the omega n value gives us 10. And we already know that k is equal to omega n square. Therefore what will be the k value? K is 10 square, that is going to be 10. So if you want to have the damping ratio of 0.5 in the system, the k required, generally k is the amplifier gain, the required gain k value we got it as 100. Now for this k value, let us find out other time domain specifications. What are they? First one is settling time. We know the formula of settling time. So settling time by default we will take it as for 2%. We also have the 5%, but for 2% let us see what is the formula. Ts is equal to 4 by zeta omega n. Zeta value we know and also omega 1 value also know. Then we by substituting this, then you will get here Ts value. The Ts value is 0.8. Then peak overshoot. We know the peak overshoot formula, that is percentage MP is equal to e power minus zeta omega n divided by under root 1 minus zeta square into 100. So if you substitute zeta and pi, and again in denominator we have in e power term under root 1 minus zeta square into 100, and it gives us nearly about 16%. Exactly it is 16.3%. So this is the peak overshoot for the problem. Next, time to peak overshoot. The time to peak overshoot we call it as the peak time. What is the peak time formula? It is pi by omega d. Omega d is again omega n into under root 1 minus zeta square. By substituting all these things here, then you will get Tp as 0.363 seconds. So this way we can solve the problem, then we can find out all the time domain specifications. Let us take another example. In this example, look at the problem statement. A system is governed by the differential equation of d square y by dt square plus 4 dy by dt plus 8y is equal to 8x, where y is the output, x is the input. Determine all time domain specification and also the output response for unit step input. So this is the problem statement. Now we'll see how to solve this. So in this case, transfer function is not available, neither closed loop nor open loop, whereas the differential equation is given. So from the differential equation we know how to find the transfer function. Look at that, the given differential equation is this: d square y by dt square plus 4 dy by dt plus 8y is equal to 8x. Apply the Laplace transform, then you can take y of s common, then it gives us s square plus 4s plus 8 is equal to, again you can take x of s common, then you will get 8. What is the transfer function? Output variable by input variable in Laplace domain. Therefore, your y of s by x of s gives us 8 divided by s square plus 4s plus 8. So we now got the transfer function. So once you have the transfer function, from this write down what is the characteristic equation and compare with the standard characteristic equation. Find out what is zeta value and omega n value, then from that we can find out all time domain specifications. Now we write the characteristic equation. How to write the characteristic equation? If you have open loop transfer function g and h, then formula is 1 plus gh is equal to 0. Whereas in this case already system transfer function is available, we assume it as the closed loop itself. Therefore the denominator is your characteristic equation. So what will be that? S square plus 4s plus 8 is equal to 0, which is the characteristic equation of the given system. Now what is the standard one? S square plus 2 zeta omega ns plus omega n square is 0. So by comparing, then you can say omega n square is 8, omega n is under root 8. So under root 8 you can easily find out, that will be 2.83 radian per second. 2.83 is omega n, undamped natural frequency. Then we can compare the second term. What is that? 2 zeta omega n is equal to 4. Then by substituting the omega n value, then we can find out the zeta. The zeta goes 0.707. Damping ratio is 0.707. And with these two information, omega n and zeta, then we can find out the damped natural frequency, that is omega d. Because in all the formulas we have omega d, so here itself we calculate omega d, later we can substitute them. So omega d is omega n into under root 1 minus zeta square. So we substitute zeta value 0.707, we substitute omega n value 2.83, then omega d is approximately equal to 2 seconds. Now, so these three are available, zeta, omega n, omega d. Let us now calculate all the time domain specifications. The first one is a delay time. We know the definitions, but I am not going to the definitions, but directly formulas available, I will use it. So TD is 1 plus 0.7 zeta by omega n. Zeta is available, omega n available. By substituting, you will get the value, it is 0.528 seconds. That is the delay time. Then rise time. Rise time formula is pi minus 5 divided by omega d. So pi is 3.14, omega d is value 2, we got it, and 5 we need to calculate. So where 5 is cos inverse zeta. So if I use cos inverse of 0.707, you will get 45 point something in degrees, nearly about 45 degrees. But convert the degrees into radians, and that radian information I need to substitute. So 45 is around 0.786 radians, then that is the phi value. Take that 0.786, substitute in the rise time equation, it goes like this: TR is equal to 3.14 minus 0.786 divided by 2, that will be the rise time. Therefore rise time value will get it as 1.176 seconds.